on. The first presentation will be airport and airfield surveillance control. If I can ask the teams that are going to be presenting next, if you can kind of line up on the side so we have a smooth transition. Marco's going to be running this one, I'm going to be running next one.
Good afternoon. We're the team working on the UTDesign project for Airside Logix. Let me begin by introducing everyone. This is Matthew Chapman, computer engineering, who's doing the electrical programming. Joe Sam, electrical engineering, also programming. Mark Hunsberry, he's handling the networking aspect of our project. Renaud Wilson, electrical engineering, he's working on the cameras. Along with me, Sam Algendra, and electrical engineering, working on the cameras. Our project deals with airport and airfield surveillance, basically for detecting FOD, or foreign object debris. Basically anything lying on a runway that could possibly damage an airplane taking off or landing. Currently, airports in the United States employ workers that just patrol the runway manually, looking for anything that might damage an airplane. The problem with that is that humans make errors, they miss things. Sometimes even inspections are missed. As with Concorde, the fastest commercial airplane in the world that crash landed after takeoff because it ran over a titanium alloy strip left over from a previous plane, which they never saw. Crash landed, killing 113 people. It was a tragedy. So a project like ours hopes to prevent such disasters from happening again. The way we're doing this is we're deploying optical sensors around the runway that automatically scan and look for anything that might damage an airplane upon takeoff. It will also be able to determine the location and the size of the object. It will send this information to the control tower, where a worker will determine whether whatever the camera has seen is a threat to airplanes, and then they will proceed by taking it off the runway. Our first semester was mainly concerned with research. Meeting with our sponsor to narrow down the scope of our project to what is manageable in the allotted time. We hope in the second, we also managed to gather all the equipment necessary, most of it at least. Camera sensors, infrared camera sensors, workstation, GPU. In our second semester of senior design, we hope to be able to put everything together and get it up and running. Would like to take any questions at this point?
So, what signs of objects do you detect?
It's down, yeah, it's down to,
How big was the piece of titanium at the Concorde? You mentioned the piece of titanium?
Yeah, it was titanium alloy strip.
Yeah, what size was that?
It was,
No problem.
it was small.
And what have you actually put together so far? You've assembled some equipment,
Yeah.
and what have you done? You've got any proof of concept, and done any software development? What have you actually done?
We have not had the time to get into install in the software development. The proof of concept is basically a flowchart. You start with,
Unfortunately, the text is a little difficult to read, so
Oh,
can you walk us through that?
yeah. So it begins target acquisition and detection as the camera sees the object. And then it analyzes its geolocation and its size using a GIS layer, or a geographical information system layer. It will send an alert, notify an operator, or send the video feed and the target information on the local location. And the operator will be able to make a collaborative decision about
So where have you got to on that flowchart with what you've achieved this semester?
start.
So how are you not going to detect planes?
How are we not going to detect planes? Well, the thing is, this project is by Airside is very, very large, and it has a lot of different aspects. So what happened is when we first got the project, it was kind of a mess because the customer didn't really determine what he wanted from us. He wanted too much from us. So we narrowed down the scope to what is manageable to us, and what we plan on working on is detection of an object that is detectable. Later on, the project will expand to tracking airplanes, even knowing which airplane is landing, which airplane is leaving, tracking everything that's happening on the runway.
Do you have an idea already how you can tell between a truly dangerous object and something
getting rid of the radar, reducing costs, and simplifying the project down to the camera level, making everything happen with just the cameras.
So you've got, sorry,
I'm sorry. So how would you detect on a runway that has fog, rain, other impediments to seeing the object?
We are also employing infrared cameras, and we're able to do it thermally.
so you've recommended back to the company to use cameras. What resolution camera sensor do you need, or what range to be able to detect the twisting of the object?
The kilometer range, was it?
What kind of system do you need? I mean, how many megapixels on the sensor? What kind of camera are you recommending to use?
They're provided by Airside Logix. They've delivered the camera. They ordered
Okay,
it.
so you said use a camera, they chose the camera, you didn't tell them which camera you wanted to use.
Well, they already have cameras as part of their solution, and so we basically eliminated the radar portion of it to reduce the cost of the overall system solution.
Okay.
And so the cameras they've already provided, we're not particularly happy with the resolution of the cameras, but we just got them delivered, last week.
So if they've already got cameras, they already have a system like this?
No, they sell.
There's systems in places in Dubai and currently working in Saudi Arabia, but they employ the radar system, the radar solution. And it's not made, it's not designed by Airside Logix. That's why they asked us, they wanted to design their own systems that they can employ here in the United States. Originally, it was also going to be using radar, but we said, no need for radar, we can do all that now.